Hello guys, welcome back to Origis Computer Classes. How are you? Hope you are doing well. Till date we have done data structures, and in data structures there were two parts. The linear data structures, which consists of arrays, linked lists, okay, stacks and queues, and another part was non-linear data structure. Now, what are data structures? Now, it is a way of storing the data in an organized manner. So, under non-linear data structures, we have trees and graphs especially. Actually, these data structures do not follow a contiguous fashion of storage, right? Like in case of linear data structures, we used to have arrays which had indexing, like at 0th index we will be having an element, then at index 1 we will be having an element, right? So I mean, it was like a continuous fashion. A long strip of memory was given. In linked list also, even if there was no indexing, but we can move from one node to another using the addresses, right? But in non-linear data structures, there is no concept of contiguous allocations, okay, or like no concept of linking any address to another address, okay. But of course, these non-linear data structures we will be implementing using linear data structures only, because other than this there are no way to implement any non-linear DSA. I mean, there is no individual approach of non-linear DSA, right? So we will be using linear data structures only to implement these non-linear data structures. Now, in non-linear data structures, the first concept that we are having is trees. Trees, 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 okay. Now, if I talk about trees, it is not that like ordinary trees, the plant kingdom trees that we see every day, not like that. You can somewhat relate to it, but see, like in our childhood we used to discuss about a family tree, right? So in family tree, like our grandfather used to come first, then their children, like that is our parents, okay, then all of us, then our children, okay. Like this way we can build a family tree, like say great grandfather, okay, and obviously also mother, okay, great grandparents, you can great grandparents, right? Then from there they can have sons. I mean, for us they will be like there can be grandfather, right? And then we can have another like there can be many sons. There can be many sons from a great grandfather, right? Because he was a person, so there can be many sons and many daughters. So from them again there will be sons as well as daughters, right? And there can be many. We do not know. So this is a concept of tree in all non-linear DSA also. So from one parent again there will be a child. Again from that child another, there will be some children. The generation to generation there will be a tree built, right? So in case of the trees that we are going to implement, it will be following the same concept. So above all, the node which we will be having will be called the root node, okay, will be called the root node. So let me just take, say suppose our great grandparents are like say represented by A, okay, Then they may be having some children, say B, C, D, right? And again they may be having some children, E, F, B has only 2 children, say suppose C has no children, doesn't matter. Again D has H, I, J, right? And this can continue up to any level, that is up to you. Now, so this node above all, A, from where the generation, from somewhere the generation has started, generation of the tree all together. So this, the first node will be called as the root node, from where the tree starts growing, right? You can relate it from where the tree actually starts growing. And the nodes, just remember, the nodes which do not have any children, the nodes which do not have any children are called our leaf nodes. So here, if I talk about leaf nodes, who are the leaf nodes? It's E, F, C, H, I, J. E, F, C, H, I, J. E, F, C, H, I, J. So these are the leaf nodes. Root node is A, and other than these, other than the leaf nodes and the root node, the nodes are called internal nodes. So internal nodes are like here, internal nodes are B and D here, right? So this is the concept of tree. Okay, so this is the root node, internal nodes B and D, and E, F, C, H, I, J, these are the leaf nodes. Fine. Now there can be questions like who is the parent of E? So parent of E, we can clearly see that is B. So parent of E will be B. Again, suppose if I like just try to relate things with human nature. Okay, so if I try to say E is a child of B, and also F is another child of B, so can I say that these nodes are siblings? So that can be called that E and F, the relation between E and F are like they are siblings. Okay, so who is the grandparent of E? That is A. Okay, like they can also ask you like who is the grandfather of E? That will also be A. Again, if they ask you who is the grandmother of E, that will also be A. Because see, there are actually no concept, because we just consider the grandfather and grandmother like grandparents the same level. That is A. That is the root node here. And even after E, if say suppose E had another node, say suppose Z, then W, again F has, it is not necessary that each node will be having two children only. It can a node can also have one child, like say suppose H can have only one child, that is say T, right? So that is also possible. It is not necessary every time that it will be having two children. If I am talking about trees, okay, if I am talking about trees. So this was the overall concept about trees. Okay, this was this A is called the root node, internal nodes, and as the tree grows, there will be children. So there can be relations. You just need to identify. You just need to relate it with human relations, nothing else. Okay. So that was the concept about trees. But the most important thing under trees that we have is our binary trees. Okay, this is the concept, this is the main thing upon which the whole tree concept is based. Okay. So binary trees. Okay, so the most important part under trees is the binary trees. Okay, so if I talk about binary trees, actually they can be classified into 4 types. That is a full binary tree, then it's complete binary tree, then perfect binary tree, and then degenerate binary tree. Okay, so actually binary tree itself is also another type, and then comes these 4 classifications. Okay, now I am coming to this, but before that let me discuss the concept of binary trees. So a binary tree is a tree which can have 0, 1 or 2 nodes at each level. The maximum nodes possible is 2, okay, and the minimum is 0. Okay, so at each level nodes possible are 0, 1 or 2. Okay, so starting from the root to the children, if I build a tree, so these are called the levels actually. Level 1, then level 2, okay, then level 3. In this way a tree progresses. So like first generation, then second generation, then third generation. So here it is like level 1, then level 2, level 3. In this way we can build a tree. So that is, so at each level, in case of binary tree, if I start from the root, so say suppose there is one root I have taken, fine. A root node should obviously be there. If I am building a tree, there should be a root. Without root there will be no tree, right? Without root there can be no tree. So if I have taught a root node, so this comes under level 1, right? This is level 1. Just take the screenshot of these 4 classifications also, as I will be progressing it. So if this is a root node, either I can leave it as it is, okay, this can stay as it is. So say suppose it has no children, so complete one node is also a binary tree, right? So only a root node it has. Otherwise if A is having children, so there is a restriction. A cannot bear more than 2 child, okay, more than 2 children. So A can have 0, that is 1 and only A, or it can have 1 child only, right? Or it can at most it can have 2 children at most, okay, at most it can have 2 children, and this becomes our level 2. Fine. Now same thing will be applicable for B and C now. So B can also have either 0, 1 or 2. So B can, say suppose B is staying as it is, and C may be having 1 child, okay, and say suppose again D wish to have 2 children, right? So there is a restriction. It cannot have more than 2 children, right? None of the nodes can have more than 2 children. Fine. So this is the basic concept of binary tree. Now the actual concept comes. So now there can be questions like, at say height HC, when there is a root node, when there is only a root node, okay, first this is level 3, level 4, okay. So when there is a root node only, if there is only the root node, what is the height of the tree? Can you tell me? What is the height of the tree? 0, obviously, nah, because it's only root. There is no one there, so its height is 0. Can I say height is 0? Yes or no? If A is having 1 child, at minimum A is having 1 child, then the height turns out to be 1. Okay, so when the height is 1, we can say that minimum it has to have two nodes. See, A and B together they are forming two nodes. Now overall, if I look at the tree, it is forming two nodes, right? If B is having another one child, say C, then the height becomes 2. Just count the number of edges for height. That will be all. Okay. So I mean not actually the height, the level actually. Level minus 1. So if this was level 1 when only there was root node, so 1 minus 1, so height is 0. Level 2, 2 minus 1, height is 1. So at height 1 there was 2 nodes. Now height becomes 2. Right? Height becomes 2. So it's level 3 minus 1. So 3 minus 1, this is level 2. This is level 3. So height 2, at most there can be, I mean the minimum there can be 3 nodes. Minimum there has to be 3 nodes, right? That is, as per the concept binary tree, each node can have one child at minimum. So sorry, minimum is 0, but if the height is increasing, it is having one child, but so at that ith level there is one child. So ultimately it is forming, overall if I see at level 3 when the height is 2, it is having minimum 3 children, right? And at max, say suppose there is only level 2, at max there can be 3 nodes. Okay, so that is maximum. So when the height is 2, at max there can be 3 nodes. Maximum. Minimum is 2 when there is no C, but maximum is C. So these we see every time. We cannot say, suppose there are 100, the height is say suppose 100 and there are 100 levels. Every time it is impossible that we build a tree and then just count the level and then bring out the height. It's a hectic job, man, and it will take your entire day. Okay, so we need to come up to some mathematical formula, right? We need to come up to some mathematical formula. Now, so say suppose when the level is, first let us discuss about levels. फिर हम हाइट पे आएंगे एंड देन डेप्थ. ओके, हाइट एंड लेवल, height and depth, these are the 3 basic concepts of tree. Okay, so if it's a root node, when the level is 1, only one node is possible. At level 1 only one node is possible, right? At level 2, can I say at max I can have 2 children as per the rule of binary tree? Okay, right? So at level 1 it is having one node. At level 2, I am talking about maximum nodes. Okay, say suppose maximum, I am having maximum nodes here. Maximum nodes at level 1, maximum one node is possible. Yes or no? At level 1 only maximum one node is possible. At level 2 maximum 2 nodes are possible, right? At level 3 maximum B, A and C can also have 2 children, that is say suppose F3. So maximum at level 3 4 nodes are possible. Yes or no? Maximum 4 nodes are possible at level 3. Okay, can I now write, so say suppose at level 1 it is having 2 to the power 0, 2 to the power 0, okay, 2 to the power 0 number of nodes. At level 2 it is 2 to the power 1, 2 to the power 1, right? At level 3 it is 2 square, Now you can clearly understand these 4 nodes. These are the 4 nodes. So if there is another level at level 4, each of these can have 2 nodes. Each of these can have 2 nodes. So 4 times 2, that is obviously 8. So at level 4 we can say it is having 8 nodes. That means it is 2 to the power 3. 2 to the power 3. Okay. Now at some book there are some authors who write that level better you start it from 0, so that you can just make it 2 to the power L only. So at say L, this is L0, L1, L2, L3, either of the thing you can do. So say suppose there is at one level I, can I say at level I, if I start the levels from 0, if I start leveling from 0, that means the maximum node possible is 2 to the power I. 2 to the power I. I hope I could make it clear. And if you start the level from 1, if you start the level from 1, if you say root node, if root node is level 1, then at ith level, at level I, it will be the maximum nodes possible is 2 to the power I minus 1. You can simply write, because at level 1 it is 2 to the power 0, at level 2 so 2 to the power I minus 1. You can clearly say that. So I am considering I am starting it from level 0. So maximum node at ith level is 2 to the power I. Clear about this? Clear about this? Now we can build a formula for height. Okay. So I am just writing now it as a statement. So you have seen it, that maximum node at ith level is, so if this is level 0, level 1, level 2, level 3, okay. So at ith level, max node at ith level is 2 to the power I. At ith level, max nodes equal to 2 to the power I, right? Now we can clearly find out the height. Okay. Now if we are talking about height, see, again let me discuss it. If there is only a root node, the height is 0. There is no height. Level 0, height is 0. Height is also 0. No height is there. Okay. Now, as soon as A is having one child, as soon as A is having one child, so I will be discussing two things. Minimum nodes at height h, okay, at height h, and maximum nodes at height h, maximum nodes at height h. Fine. So let me bring up the concepts. So minimum nodes possible at height h is, see, when the height is 1, I can say this is height is 1 because only one child, na? So at level 1 height is 1. So there can be maximum 2 nodes. If I look at the nodes, there can be at max 2 nodes. Okay. If I look at the overall tree, and if I talk about the level, at level 1, so maximum nodes possible is 2 and minimum is 1. Right? Again, say suppose A didn't have another child, so B is having one child, C, so height is 2, because see, this is a minimum possible. A can have one child and again B can have one child, so minimum possible. So at when the height is 2, minimum possible is minimum nodes number of total number of nodes possible is 3. At look at the overall tree, the total number of node has become 3, A, B and C. Yes or no? And so if I talk about the minimum nodes, it can be a straight tree like this D, and it will be continue one side only. So minimum possible height is, if I talk about the levels, at level 1 it was 2, at level 2 when the height was 2 it is 3, level 3 it is 4, at 4 it is 5, 1 2 3 4 5. So minimum height possible at any ith level is, if I talk about the level I, or if you say height also, h plus 1. You see, I can say also the height is 4 in this tree, height is 4, yes or no? Height is 4. From root node it is level, it is like this edge is h1, then h2, h3 and h4. So total height is 4 and the total number of nodes are 5. So minimum possible, minimum height, minimum number of nodes possible at height h is h plus 1. Fine. That is what it is. Now comes the maximum nodes possible at height h. So how to calculate that? It is a bit tricky, but it is easy. If you have to know a basic maths, AP and GP series, so only GP series sum you require. Okay, so let me elaborate it. Say suppose at level 1, now I am talking about maximum, right? Maximum. So maximum possible in case of binary trees 2. At level 1, maximum 2 children can be there. A can have 2 children. Na? At max A can have 2 children. Say suppose B and C. Right? I am just aligning it to more left, towards left. The tree I am aligning it towards left. Okay. So B, C at level 1. So this is my root node as it is. This is my root node. Level 1. Sorry, level 0, say level 0 and level 1. Fine. Level 0, level 1. At level 2, it can be D, E, then F, G. So at level 2, maximum it can have, so B can have 2, C can have 2, so maximum is 4. Altogether, maximum I can have 4 children, 4 nodes at level 2. At level 2, I am not talking about the overall tree. Okay, so at level 1 I was having 2, and at level 1, and at level 2 it is 4. So at any level I can have 2 to the power I nodes, as I have already discussed. It is 2 to the power I nodes I can have at any level. Maximum children at that level, at ith level, maximum nodes possible at 2 to the power I. So if I have to calculate the overall, what is the total nodes, what are the total nodes in the overall tree, what are the total nodes in the overall tree, say suppose this is 2 to the power 0, at this level it is 2 to the power 1, at this level it is 2 to the power 2, and dot at ith level it is 2 to the power I. So can I say it is a sum of all these? The sum of all these will give me the total nodes present in the tree. That will be the node possible at height h, maximum node possible at height h. So let me add them up. So 2 to the power 0 plus 2 to the power 1 plus 2 to the power 2 plus dot 2 to the power I. Yes or no? Can I say this is a GP series? Can I say this is a GP series? So what is the formula of summation for GP series? Formula of summation for GP series, it is nothing but I am writing here, it is A times r to the power n minus 1 by r minus 1, where A is the first term and r is the common ratio. Yes or no? This is the concept, this is the basic maths we know from GP series. So tell me, what is the common ratio here? Common ratio, let me just consider these two. So 2 to the power 1 by 2 to the power 0. 2 to the power 1 by 2 to the power 0. So 2 by 1, that is 2. So r is 2 here, r is 2 here, r is 2 here, alright. And A is 2 to the power 0, because the first term I am having is 2 to the power 0. First term I am having is 2 to the power 0. And n, that is the total number of nodes I am having. I mean, from 0 to n, how many terms I am having, right? How many terms I am having. So just tell me, from 0 to 9, how many numbers are there? From 0 to 9, if I include 0 also, how many numbers are there? 10, na? It is 10, it is 10, yes or no? From 0 to 9, if I say there are 10 numbers, 1 to 9, 9 numbers, and if I include the 0, it's 10. From 0 to 10, how many? 11. So from here, if I say 0, 1, 2 up to I, so it's always says, so 0 to 9, it is 9 plus 1, that is 10 numbers are there. From 0 to I, so n, I can say it is I plus 1. Okay, or I can say if at a height, see it is same concept at level I also, or I can say it is like h also. I can say h also, because at height h also, because at level the height is h. I can say if this is level 2, the height was also 2. So if this is level I, okay, and if I can say this is level h, so height is also h. So just consider it to be h. You can also consider it to be I. If I consider it to be I, so as because we are discussing about height, so just considering it to be h. Okay, so it is like 0 to h, so it is h plus 1, right? H plus 1. So just now put the values in this sequence. So it is A is 2 to the power 0, R common ratio is 2, to the power n is h plus 1 minus 1 by 2 minus 1. Now 2 to the power 0 becomes 1, and 2 minus 1 is, as you know, it is 1. As you know, it is as it is 1, right? So what is remaining is 2 to the power h plus 1 minus 1 is our maximum nodes possible at height h, right? So it is 2 to the power h plus 1 minus 1. So this is all about all the basic concept of binary tree, and you need to just remember these three formulas. This is very essential. In our next lecture, we will be now discussing, so these will become, these four subtrees, these four subtypes of binary trees will become very easy for you now. So in the upcoming lectures, we will be now discussing about these four subparts. What are the four subparts? That is a full binary tree, the complete binary tree, right? The perfect binary tree, and the degenerate binary tree. So till then, bye bye guys, take care of your family. Thank you.